in this problem, we're told that Alice and Bob live in a town with 100 other people. And we're going to call the set of those 100 other people C. And we're also going to let A be the set of people in C who are friends with Alice. So A is the set of people in C who are friends with Alice. Friends with Alice. Similarly, we're going to let B be the set of people in C who are friends with Bob. And we're going to suppose that for each person in C, Alice is friends with that person with probability 1/2, and the same for Bob. So for every person in C, the probability that that person P is friends with Alice is the same as the probability that that person P is friends with Bob, and that probability is 1/2. So where P is some person in our set C. And all these friendship statuses are independent, meaning knowing that a person is friends with Alice doesn't tell us anything about whether that person is also friends with Bob. So we need to compute the probabilities of a few things. So in part A, we're told consider the subset of those 100 people. Let's call that subset D. And we'd like to find the probability that A equals D. So what does this equation here mean? This equation means that out of all the people in D, we'd like that, for every person in D, we'd like that person to be friends with Alice, and for all the people that are not in D, we'd like those people to not be friends with Alice. And remember that friendship statuses are independent amongst people. So for every person in B, for every person in D, the probability that they're friends with Alice is 1/2. So we're going to get 1/2 to the power D, to the power the cardinality of D. This is the product of the probabilities of a person in D being friends with Alice times 1/2 to the power the cardinality of C minus the cardinality of D. So for everyone else who's not in this set D, we want them to not be friends with Alice, but the probability of not being friends with Alice is also 1/2. So that's 1/2 raised to this power, and we get 1/2 to the power cardinality of C. Now in part B, we're asked to find the probability that A is a subset of B. So what does this imply? This says that we want to find the probability that for every person who is friends with Alice, we'd like to know what's the probability that they're also friends with Bob. Now remember that these friendship statuses are independent of each other. So for a given person in the set A, the probability that they're also friends with Bob is 1/2, and these are independent of each other, so the probability that they're all friends with Bob is 1/2 to the power cardinality of A. So for every person in A, we want the probability that they're friends with Bob, and that probability is 1/2. Now moving on to part C, we're asked to find the probability that A union B equals C. This means that every one of these 100 other people is either friends with Alice or friends with Bob. Well, let's do the following. Let P be a randomly selected person, be a randomly selected, so this is without replacement. We're randomly selecting people. Selected person from our set C. So from this 100 people, we randomly select a person, and we'd like to know what is the probability that this person is either friends with Alice or friends with Bob. So we know that this probability can be computed by saying what is the probability that this person is friends with Alice plus the probability that this person is friends with Bob minus the probability of the intersection. So this person is friends with both people, with both Alice and Bob. So this becomes 1/2 plus 1/2 minus a fourth, and we get 3/4. So notice we found that given a random person from C, the probability that this person is either friends with Alice or friends with Bob is 3/4. And we'd like this to be true for all the people in C. For every person in C, we'd like them to be friends with either Alice or Bob. So this is going to be 3/4. The probability is going to be 3/4 to the cardinality of C. Again, the friendship statuses are independent amongst people. So for any of the people, the probability that they're friends with either Alice or Bob is 3/4. And so the probability that they're all friends with either Alice or Bob is the product of those probabilities, the product of the products of these 3/4. And how many of them are there? There are 100 of them, the number of people in C. So the answer is 3/4 to the power cardinality of C.